Hello, thank you for joining me today. My name is Alex Cahn. I am a Senior Partners Alliance Manager here at HashiCorp, and I hope everyone is having a great MongoDB world. So today we're going to talk to you about future-proofing your data infrastructure with advanced security capabilities. So as I mentioned, I'm here from HashiCorp. And so HashiCorp is a leading cloud infrastructure automation company. And so basically what this means is we have a set of software that really is enabling the provision, securing, connecting, and running of apps and the infrastructure that is supporting those applications. So how do you quickly be able to deploy an application, spend some infrastructure, be able to secure it, those sorts of aspects. And so we have what we call the cloud operating model. And what the cloud operating model is really enabling companies as part of this new digital transformation. So we have this trend of moving what we call from the static infrastructure where you used to have your data center to moving to dynamic infrastructure we're using cloud. And so we've seen this shift, from effectively running on mainframes, which we were doing back in the 70s, to slowly becoming more operationally agile. So this was with the advent of the client server relationships. And then we started seeing folks thinking, well, okay, how do we make it more advantage of our data centers, and we implement virtualization technology, which then led to the rise of your private cloud, which now means that, in some cases you'll need to move to a public cloud. And in a lot of cases, you'll need to be multi-cloud. So you can be a private cloud and plus multiple public cloud providers. And at this point, we're seeing that, most companies are in this state where they have adopted multiple clouds. And so this is the world that we're living in. And you can kind of even see this in the journey of folks who are attending this conference in terms of where they've moved from let's say they were self-managing a MongoDB enterprise cluster and really adopting MongoDB Atlas. And there's a number of reasons to do this. And looking at one of the case studies we've seen actually of a company that's used Terraform to help them spin up to and move to MongoDB Atlas was Liberty Mutual. And Liberty Mutual said, hey, we need to live in a multi-cloud world, so we need to be able to have our data reside in multiple clouds and not be solely dependent on one. We need to be dynamic. We need to be able to create new projects at will. We need to make sure those projects have best practices from a storage perspective, that we're doing the best things around sharding. We don't have to worry about those operational nightmares. And then that we're also getting security by best practice. And security is obviously one of the things that we're near and dear to our heart. And so really trying to figure out how do you do best practices of security by design. And you'll hear this as a constant theme throughout the presentation. And so as organizations are really adopting this multi-cloud strategy, there's a lot of concerns that you have, and especially around secret sprawl. And so what is a secret? A secret is most commonly seen as a username and password, but it could be an API token, it could be an encryption key, it could be PKI certificates or X509 certificates. It's all of these sources of access to various different systems. And we're starting to see this be peripheral. We're starting to see this throughout the infrastructure of companies. And so this is the easy example of this is being able to check in a username and password for access to your database and to your code. And this starts leading to credential leakage, right? Which is huge now for companies today. The number of reports that we see where credentials were leaked in code, they were accidentally found in a public environment, which has led to a data breach. And so you need to start really addressing, as your company is adopting modern practices, GitOps workflows, for example, where you're part of the principles, and there's can be a little bit of controversy around this. Do you check in your secrets into your GitOps code, or do you just provide references to those secrets, those sorts of pieces? Now, with all of security and ease of use do not necessarily go hand in hand. And so you really start looking for, how do I enable my developers, my administrators, my operators, all these folks to be efficient while adhering to best practice? And the answer to this, of course, is going to be always around automation. The more that you can automate, so building controls, you have less prone to user error. It'll improve everybody's efficiency and productivity. Is having a system that gives you this operational efficiency, which means there needs to be automation built into it. And the last one is really trying to take hard problems to solve, and again, giving engineers or developers best practice by default. And so this is with the data encryption. Encryption is extremely hard. Number one is encryption is changing on a regular basis. You have outdated algorithms, and then you have to get into this world of encryption key management. What happens with if you use a key too often? Can you rotate it? Can you issue new versions? What happens if the key is leaked? How quickly can you invalidate the key? All of those sorts of pieces come down to is how am I encrypting the data that I'm going to be storing at rest or in flight, or all those aspects. And to expect your developers or engineers to know how to do all these things is a large task, because it's really hard to get right. Even for experts, it's hard to get right. So it's a lot of complexity, a lot of concerns. And so HashiCorp has a product which we call Vault, which is really trying to help companies address these concerns. And so Vault is a tool for keeping secrets and application data secure in the cloud, as in the cloud operating model. And so basically, what does this mean? Well, Vault will really look at how do I give clients or machines or applications a sense of identity, so we know who those applications are. We can track them, we can audit them, we can log it, we can assign different roles and different permissions in order to be able to start controlling and monitoring the access to these secrets, and really doing this in a controlled fashion. And so we want to be able to leverage existing systems of identity to be able to validate these clients into it. The next thing is, and this is probably one of the biggest use cases of Vault, is around secrets management. So no longer do you want to have all of your secrets in different locations, checked into files, stored on people's computers, written on a notepad, all of these things. You're actually going to essentially storing and now protecting these secrets across all of these multi-clouds, applications, depending on wherever you need to consume these secrets. And the last thing that Vault does is provide an automated way to do data encryption, not only to encrypt the data, to provide the key side encrypted data, and to integrate with different systems to do this, again, so you can adhere to these best practices. And so let me just briefly walk you through how Vault actually works. So we have a client, and so, oops, let me go back one slide. And so let me explain to you how this works. So we have a client, and the client, like I said, can be an application, could be a person, could be a machine, whatever it is, and it's gonna authenticate the Vault. Vault will use some trusted source of authentication. So whether it's an IDP, or whether it's an IAM provider, whatever, a cloud provider, etc., whatever it is, once we've been able to authenticate that, we will pass back to the client a token, and that token will then go into this authorization model. So as we mentioned with zero trust, right? You want to authenticate everything. You're not trusting anything, and you need to make sure that you're authorizing the right systems to have the right access to the right secrets at the right time. And so this token will actually have a policy attached to it, says that you're allowed to access a downstream system. And so the reason this is important is this will kind of come into the demo that I'm going to do in a few minutes, which really kind of shows how this model works. But all this comes down to being able to audit what's happening in the system, and to be able to create finer grained controls on accessing it, making sure that your application server is only able to access your database server. It doesn't need to get access to any other kind of secrets inside of your infrastructure. And so we have this guiding principle of identity brokering. And really, this is how do we have your, in a lot of cases for developers, you're going to deploy your application across many different environments, whether it's your dev and UAT in production, or whether it's reduction charted across multiple clouds. And all this is starting to add a lot of operational complexity for your operators. And so what you want to be able to do is leverage the underlying system source of identity or of authorization for this, but you're still going to have a single identity for your application. So in this case, it's our Acme app. Now it can be deployed. So we're going to say if our app that's running in AWS needs access to secret, well, Vault will communicate with AWS, say, hey, is this the application? Yes. Okay, great. And now when I log into Vault, I'm going to get a single policy that is saying you have access to your MongoDB Atlas and be able to log in. Because we're able to spread this out, again, this simplifies the workflow for your administrator. So you say, okay, Acme app, regardless of where it comes from any one of the clouds, I know it's Acme app. I'm going to assign a policy, and therefore you can only get access to your database. And the idea about this is building an automation reducing this operational complexity in workloads. And also the nice thing is for developers is it doesn't really matter now where the application is deployed, because it's always going to be able to access Vault. And now for you, it creates a simpler environment for you to be able to build in your connectivity as part of your application. So the main use case, especially when it comes to database and us being that MongoDB world, this makes a lot of sense, is how is my application getting to my database? So in the old world, you would have to, you have your DBA, log in, create a username and password, you issue it to your application. Maybe you store it in a config file, and all of a sudden now you check in your config file and your application database credentials are now leaking out into the world, and we're in a whole world of pain. So with Vault has this concept of being able to create secrets, attach leases to them. So being able to create short-lived secrets, automatically expiring those out, and forcing applications to be able to refresh and not to do insecure practices. And so we have a couple different types of kind of database operations that we can do, and it's depending on the use case. So what will happen is Vault will be able to connect to a database. So in this case, let's say a MongoDB Atlas cluster, and it will be able to manage either long-lived static users, so typically like service accounts, and be able to manage the passwords for those service accounts. So you're regularly rotating the passwords and being able to supply that password to whatever application or service that needs to get access to it. And so basically what you can do now is you can create password policies. You can say, I need to rotate the password every 30 minutes, or every 30 seconds, whatever it is, and Vault will take care of all of those aspects. The second thing that we do is dynamic database credentials. So rather than even having a static username in there, let's actually create dynamic users. So let's create a user. It'll be active for as long as the application needs it, and then Vault will drop it. The next time the application needs access to the database, then you can create a new user and be able to do this. So, depending on your needs, this could be a very short-lived user, or it could be a little bit longer-lived user. But what happens now is you have a mechanism to control and automate how you're creating and creating users. So your developer doesn't need to know how to create a user. Your operators of your downstream systems don't need to worry about it. Am I having to mint a new user every time? What happens if it leaks? I have an audit trail of everything that's happening. And so again, you're able to now have almost by default best practices in security. So this is one of the primary use cases that we see with Vault, with databases. The next use case, and what we talked about before, is key management. So key management, again, is hard. So how are you encrypting your data at rest? What are the encryption keys you're using? What is the key length? What is the key type? How are you doing it across all these disparate systems? It's just an operational complexity nightmare. And asking like an engineer and a developer to say, hey, you have to be using the right key at the right time, all that, it becomes a huge challenge. And so typically companies will move to use a key management service, so KMS, where the keys can be issued. You can do the lifecycle management of the keys. You can control the keys as a customer rather than depending on downstream services. So you have what is known as a root of trust. And so we've set up some integrations between Vault and MongoDB, both MongoDB Enterprise as well as MongoDB Atlas, where Vault can actually provide the encryption key that is using to store to encrypt the data at rest. And we have also just done a new integration with MongoDB Atlas's, MongoDB's client libraries, so you can do field level encryption. So this is especially used for encrypting data before it even lands inside the database. So we see this oftentimes with very sensitive data, whether it's PI data, HIPAA data, PCI data, all those sorts of components. You can actually encrypt them and use a key that is stored and managed by Vault, set up with MongoDB's client library, so using whatever language of your choice in order to perform these advanced encryption activities. And the nice thing is Vault is taking care of all the management of the key. You don't have to worry about it. It's just set up and go. So as Mongo and HashiCorp have been partners for a long time, and we've managed to build a lot of integrations. The one integration that I haven't talked about a lot is our integration with the Terraform provider. So what companies will use, and we actually have a case study, as I mentioned, to Liberty Mutual, Terraform is a tool for doing infrastructure as code and being able to programmatically create new infrastructure and building an automation. So, one of those use cases is if you have a business unit who needs to get access to a new project in MongoDB Atlas, you can actually use Terraform to kick off these jobs, do it in an automated fashion. So you again, adhere to best practices. You can also automate this, set up on jobs, schedule it, remove infrastructure, control costs, all those aspects. And this is really where Terraform comes into it. So I'm gonna hop into a demo. It's gonna be a live demo, so hopefully the demo gods will be good, even though this is a recorded session. And I'm gonna put on effectively two hats. My first hat is I'm gonna be a MongoDB Atlas administrator, as well as a Vault administrator. So it's kind of two personas built into one. And then I'm actually gonna be the developer and showing, or an application and showing how I can retrieve a secret from Vault. And so I'm gonna hop over to my Atlas cluster, and I'm going to show you real quickly. So I have my Atlas cluster here. I have only my DBA's username, a gentleman named Alex, and I don't have any other users in there. And if I look at my my ability to how I'm going to configure Vault to be able to talk to Atlas, I need to be able to provide an API key. And so using the project access manager, I can create a new API key. So this one, you'll see I have a public key that I've used to do this. I'm going to have the private key in here. And this is what I need in order to establish connection from Vault to MongoDB Atlas. Now I'm going to be using HCP Vault, which is our managed service offering for Vault. So you no longer have to stand up and run your own infrastructure. And so it's just already been deployed. I don't have to worry about running it. And because operators and developers often live in the terminal, I'm actually going to do a lot of this action from my terminal. So I have my public key that I provided to my Vault operator. I've generated my private key, provided to my Vault operator, and now my Vault operator is going to come in and create a new database secrets engine, and then actually establish the connection between HCP Vault and MongoDB Atlas, and then be able to start configuring the connections. So let me just real quickly go back to our database screens, because we'll be able to see this in a second. And I'm going to hop over to VS Code. So the first thing that I've done, and I've set up my environment, is I've created a couple environment variables, one for my Atlas keys that I'm going to be used as part of my configuration, as well as I'm going to now make sure that I can see my HCP Vault cluster. So I'll do this. And also, because we're running Vault Enterprise and HCP Vault, I'm going to set up my namespace as well. And let's just do a quick Vault status and see what's going on. So cool, we have connectivity in my Vault. I can see that I'm running it out here in AWS. So that's fantastic. So the first thing I'm going to do now is I'm going to log in to my cluster. Now there's many different ways that you can do this. Today for the demos, I'm just going to use user password. So username. And now I've logged in. So, and if you remember what we were talking about earlier, right, where we log in, we authenticate. In this case, I'm authenticating in the Vault. I get a token. So I get my token here, and I actually now have a policy. So you can see I have some policies so to allow me to do certain actions inside of Vault. So let's go ahead and clear our screen. And so we're just going to see what secret engines we have running. So right now this is actually a blank system, so we don't have much. So what we're going to do is we're going to create our MongoDB secrets engine real quickly so we can start generating our credentials. So basically what we're going to do is we're going to say, hey, create a database secrets engine at the path MongoDB Atlas, and do that. And now we can rerun our list, and we see that we have the new database secrets engine called MongoDB Atlas. So the next thing that my administrator is going to do is oops, sorry, let's try this again. Is we're going to configure our connection to MongoDB. So we're going to create a connection called my MongoDB database because I'm original. And we're going to say it's using the MongoDB database plugin. And we're going to have roles. So roles in Vault are a way for us to create access control. Just like you notice I said I had a HCP-root control when I logged in. This is also saying for us to be able to create different types of users that can log into MongoDB. So for example, maybe you want to create a user that has read-write, or maybe you want to create a user that only has read-only access. So you can go ahead and do this, and we can create multiple types of roles in this. And as I mentioned, I had already set up my Atlas key, my private key, and then now I'm just pointing it to my MongoDB Atlas project. So looks like it's worked. The next thing we're going to do is, as I mentioned, we're going to do our role. So this is where we can be able to, I'm sorry, 1 second, I'm just copying that command. Say what type of database user do we want to create? In this case, I'm going to create an admin. It's going to have the role of Atlas admin. And the most important thing is we can define the time to live of how long this user is going to exist. So for the sake of demos, I've actually created this one. They're only going to live for 30 seconds. And then if the systems can go ahead and renew credentials, but the maximum time this user will live is 24 hours. So again, security of not having long-lived users, not having these permanent credentials, etc. So let's go ahead and create my user, and now I'm going to log into my MongoDB Atlas, and we should see in just a second a user being added here. Let me go ahead and refresh. Oh, sorry. I just created the role. I didn't actually create the user. Jumped ahead on my own demo. So we've created the role. That's great. And now let me pop over to my demo. We're going to talk about this next set. So I'm now the developer. It's assume or the application. So we're going to make a little bit of an assumption. Say you've already authenticated into Vault. You now have the ability to retrieve credentials. And so if I go back to my terminal, the nice thing about this is all I have to do is log into so whether this is via the API call or via the SDKs that we have for the developers, is effectively you're going to run one Vault command, which is Vault Mongo read. At this point, this is where we're going to create our users. So we have a username, a vtester, a bunch of JM stuff. We have the password. Now, if I go back to my MongoDB Atlas cluster, we should see our vtester in here. Now, what will happen is if we don't do anything and renew the lease of this in about 30 seconds, we'll see this user be dropped. And as you saw here, it's an Atlas admin, but as part of this setting up different types of roles, we can actually change the MongoDB role in here. And so, and then the other piece that we can do as we're looking at what our activity is let me go ahead and refresh the screen and see where we are. We can see that Vault is actually already deleted the user. So let's go back into here and we should see the user go away. Perfect. So let's have a look. And now notice at the timestamps, so at 4:52:16, Vault went in. 30 seconds later, it actually dropped the user. So all of this was done in an automated fashion. So I didn't have to worry about doing it. My application knows how to go and get a new user, and everybody's happy. As you can see, we can do all this stuff in probably 30 seconds if we're being efficient. So let me hop back to my presentation. And so this really concludes it. Some resources for folks to check out, please. We have our integration page. We have the case study of Liberty Mutual. There's some resources. Please check out the Vault documentation, the Atlas documentation. And thank you very much. Wish everybody a great conference and have a great show. Thank you very much.